Imagine a scenario where the brightest minds on the planet decide to drill a hole in the shell of an armed atomic bomb, figuring that'll help it cool down and not detonate. Sounds like total insanity, right? Yet that's exactly the kind of audacious strategy researchers are discussing when it comes to the Yellowstone supervolcano. This could turn out to be either humanity's salvation or the trigger for our extinction. Go ahead and smash that subscribe button, because we're about to dive straight into the inferno. Most people see Yellowstone as nothing more than a scenic nature reserve with spouting geysers and cute bears. But behind that pastoral landscape hides a true monster. This isn't just a tall mountain with a crater, but a colossal storage tank of molten material, comparable in size to a major metropolis, that's breathing and building up power for an attack. The last time its fury burst out was 640,000 years ago, and geologists are anxiously watching the calendar because history has a habit of repeating itself. The trouble is that this supervolcano generates incredible volumes of heat, and although a significant portion of that energy evaporates into the sky through hot springs, it's still not nearly enough. The internal magma reservoir keeps heating up, and the pressure inside it relentlessly increases. NASA specialists ran the calculations and figured out that if we could lower the magma's temperature by just 35%, the volcano would most likely lose its explosive danger forever, becoming just a sleeping giant. And here's where a bold project enters the arena, created by engineer Brian Wilcox. The essence of the plan involves drilling wells around the perimeter of the caldera, not into the lava itself, but slightly off to the side, into the superheated rock. Water would be pumped into these shafts where it would absorb the heat, transform into steam, and rise back up, spinning the turbine blades at power plants. Looks like a flawless scheme for saving the planet. This strategy solves two problems at once, because we're not only cancelling the end of the world, but also gaining a resource of fabulously cheap and virtually eternal clean energy. Electricity at a cost of $0.10 per kilowatt could supply power to all the surrounding lands for tens of thousands of years. The region's economic indicators would skyrocket to stratospheric heights, and the risk of total extinction would disappear. But as soon as we move from theoretical calculations to real action, a genuine thriller begins. Breaking through to a depth of 10 kilometres in an area with unstable geology is nowhere near the same as digging a well in your backyard. The slightest miscalculation in the equations could lead to us triggering the very horrific eruption we're trying so hard to prevent, instead of cooling the depths. The main nightmare for geologists is connected to the phenomenon of decompression. The magma masses beneath Yellowstone are oversaturated with gases dissolved in them under monstrous pressure, like carbon dioxide in a sealed bottle of soda. If we accidentally damage the cork of that container, meaning the roof of the magma chamber, the pressure will instantly collapse, and the gases will begin expanding at explosive speed. Remember what happens when you vigorously shake a warm soda and suddenly rip off the cap. Now imagine that instead of sweet beverage, you've got millions of tons of red-hot rock and volcanic ash in there. Drilling operations could spawn cracks that weaken the roof's strength, and then there'll be no stopping the catastrophe. The ancient dragon will awaken not because its time has come, but because we ourselves poked it with a sharp spear. There's another risk determined by the very physics of magma. We're used to imagining it as a flowing liquid, but in a calm state it's more like a viscous porridge of crystals and molten material. For the volcano to become a threat, that sludge needs to become more fluid. The paradox lies in the fact that our intervention could shake up the fragile balance and activate the melting of already solidified zones. History remembers cases when drilling in volcanic regions turned into problems. In Iceland, as part of the Krafla project, the drill accidentally hit a magma pocket at a depth of just 2 kilometres. The tool simply fell into the molten substance, and a fountain of liquid glass burst out from there. They got lucky back then, and no tragedy occurred, but Yellowstone is a monster of an entirely different calibre. If the darkest scenario materialises, the consequences will be lightning fast and monstrous. The Yellowstone explosion in power would exceed the Mount St. Helens eruption in 1980 by thousands of times. The shockwave will destroy all forms of life within a radius of hundreds of miles, and cities like Salt Lake City or Denver will simply vanish from the face of the earth in a matter of minutes. However, the physical destruction of the surrounding areas is just the prelude to the end. The true killer will be the ash. A gigantic cloud will shoot up into the stratosphere and wrap most of North America in a thick blanket of grey dust. This isn't ordinary dirt, but microscopic glass fragments that turn lungs into a concrete block when inhaled. Aircraft engines will stall, and electrical grids will fail. America as we know it will be buried alive. The agricultural belt where the lion's share of wheat and corn currently ripens will turn into a lifeless desert for long decades. But the trouble won't be limited to one continent. Winds will carry volcanic aerosols across the entire globe, forming a screen that will reflect the sun's rays. A long volcanic winter will arrive. The planet's temperature could crash by 10 or even 15 degrees. This means widespread crop failure, famine, and the collapse of the global financial system. Imagine that summer simply doesn't come. Snow falls in July in both Paris and Beijing. Civilization will face a brutal resource crisis leading to wars over food and drinking water. The irony of fate is that in trying to avoid exactly this ending, we might become its scriptwriters ourselves. The NASA project is estimated at approximately $3.5 billion. That's mere pennies against the backdrop of potential damage from catastrophe, but the price of error here is infinitely high. Who will dare to take responsibility for pressing the start button on the drilling rig? Researchers argue until they lose their voices. Some claim that inaction is even more dangerous because the eruption is inevitable. It's only a question of the date. Sooner or later, nature will pull the trigger itself, and then we'll bitterly regret that we didn't try to release the excess pressure while we had the chance. This is the classic trolley problem dilemma, except all of humanity is currently on the tracks. Other experts point to the fact that our knowledge about the structure of the deep Earth is too limited. Current methods of scanning the Earth resemble an attempt to guess the contents of a Christmas present without opening the box, just shaking it a bit. We can make out general contours but don't see the details. And in something as delicate as supervolcano surgery, every millimetre is critically important. Skeptics also bring up the phenomenon of so-called induced seismicity. We already know that pumping water into underground layers during shale oil extraction can trigger earthquakes. The Yellowstone area experiences thousands of small tremors, annually as it is. What will happen if we add lubricant there in the form of water under enormous pressure? Won't we thereby trigger a shift in the tectonic plates? Imagine an open heart surgery being performed by a surgeon wearing boxing gloves, while the operating room lighting constantly flickers. That's roughly what our current attempt to intervene in geological processes of this scale looks like. Drilling technologies are advancing, but the risk level remains off the charts. However, alternative viewpoints exist. Some volcanologists believe that Yellowstone's magma chamber currently resides in a state quite far from critical, and we've got thousands of years in reserve. Why risk it today if our descendants will probably invent safer methods like cooling through nanorobots or something we can't even imagine yet? But drilling advocates counter by stating that we need energy here and now. Yellowstone could transform into the heart of a new energy revolution for the United States. Imagine a gigantic geothermal plant operating without carbon emissions, not dependent on the whims of wind or sun, and providing stable power. That's too tempting a piece of pie to just wave off. A curious fact that few people mention is that water circulating in such a system could become poisonous. Passing through the rocks, it would become saturated with arsenic, mercury, and sulfur. If a leak from the pipeline system occurs at the surface, we'll get a local-scale environmental catastrophe even before the volcano deigns to wake up. Additionally, the cooling process itself would stretch over thousands of years. This isn't an instant effect. We'd start pumping out heat today, and the result would only become evident after many generations. Is current society ready to invest billions in a project whose fruits will only be seen by our great-great-grandchildren? In a world of short-term investments, this sounds like a pipe dream. Nevertheless, the very concept of controlling natural forces excites minds. We're used to feeling like masters of the planet, reversing rivers and draining seas. Taming a supervolcano would be the crown jewel of human engineering thought, proof that we've outgrown our fear of nature's forces and brought them under total control. But nature knows how to cruelly punish excessive arrogance. History is full of examples where human intervention led to unexpected disasters. Remember at least the rabbits in Australia or the tragedy of the Aral Sea. Yellowstone is a system whose complexity we're only beginning to comprehend, and going at it with a drill might turn out to be the height of hubris. By the way, here's a little known fact. Beneath Yellowstone hides not one but two complete magma chambers. The upper one is more viscous, and the lower one is a huge basalt lens feeding the upper chamber. NASA's plan only affects the upper part. But how the lower reservoir will behave if we start cooling its roof, nobody can predict with any precision. There's also a legal aspect. Yellowstone sprawls across the lands of 3 states at once: Wyoming, Montana, and Idaho. Who will own the energy? Who will bear responsibility for the risks? If the experiment doesn't go according to plan, lawsuits won't help resurrect destroyed cities. Bureaucratic hell could bury the project faster than geological difficulties. Political will also plays a colossal role here. No president wants to go down in history as the lunatic who accidentally blew up America. That's why the project remains on paper for now, in the form of theoretical schemes and computer models. However, energy shortages and climate shifts might one day force politicians to take this desperate risk. We're frozen on the threshold of an amazing choice. On one hand, safe inaction and hope for luck. On the other, active intervention with the risk of destroying absolutely everything. This resembles the plot of a Hollywood blockbuster, except the special effects here will be real and there won't be a second take. Perhaps the solution will be some kind of compromise. Drilling to shallower depth, using closed-loop systems, or prolonged testing on less dangerous volcanoes. Science doesn't stand still, and what seems like nonsense today might become the safety standard tomorrow. But for now, Yellowstone breathes quietly, releasing steam and waits for our verdict. Every time you watch footage of Yellowstone's enchanting multicoloured springs, remember that's just thin skin on the body of a leviathan. We humans are like mosquitoes landing on a sleeping lion's back, discussing how to use its warmth for our own needs. The main thing is that the lion doesn't twitch in its sleep. At the end of the day, the question of drilling Yellowstone is a question of trust in science. Are we capable of calculating all the variables in the equation of chaos? Or are there boundaries beyond which humans shouldn't venture? Energy is tempting, security is important, but species survival comes first. Write in the comments what you think. Should scientists take the risk and start drilling for energy and salvation from eruption? Or is it better to let sleeping dogs lie? Your opinion is extremely important for the algorithms, so don't hold back on words.